Okay, so right here, this guy. This is figuring out, this is using standard deviation to measure distance. So how do we measure distance within data in statistics? We use standard deviations, which kind of makes sense. It's an inherently useful tool for distance because it's how far away the data points get on average from the middle. So I can use that distance to measure how far apart things are. So, why does this formula make sense? Let's say that, right, stay with me. Let's say that this room, if that's the 0 mark, right? That's the 0 mark, and then that's the 5 foot mark, and so forth. Are you guys with me? So if I'm standing on the 7 foot mark, and I want to get to the 10 foot mark, if every step I take is 1 foot, how many steps do I have to take to get from the 7 foot to the 10 foot mark? 3. Ooh, it's amazing. What if every step I take was 1.4 feet? How many steps exactly to go from the 7 foot to the 10 foot mark? You can do it. How far do I have to go? From the 7 foot mark to the 10 foot mark. How far do I have to go? 3 feet. And every step I take is 1.4. Right? If I go 2 steps, did I make it? No. So what I would do is I'd say, how far do I have to go? 3 feet. How big is each step? 1.4. So 3 divided by 1.4. That tells me how many steps fit into that distance. You guys kind of with me? So that's what that formula is. How many standard deviations fit into that distance? It tells me how many steps I got to take to get from the mean to the data point. Can this come out negative? Of course. That would just mean the data point is below average, right? This is what's called a z-score. Oh shit. Make it stable. Oh well. Z-score. Stay with me. So what data point are we interested in?
How much of the data?
No. What data point? 10. What's the mean? 6.5. What's the standard deviation size? So whatever the hell that is. 1.4 roughly? Sorry? Yes? 1.3? Yeah, sweet. All right. So around 1.4. I got to show off every now and then. I know math, so it's my one skill. So a z-score. What can you tell me then? If the z-score is 1.4 roughly, that means that's hilarious. That I just use the same number. If the z-score is 1.4, that means that data point is 1.4 steps, 1.4 standard deviations away from the mean. Since this is a grade on a quiz, that's good. You scored well above average because it's positive, right? If you got a negative z-score in a test or a quiz, that's bad. That means you're below average. This is the one that freaks people out down here. I don't blame you. But what I'm trying to do with this is to see how much data will I catch if I go out 1 step from the mean. It's kind of like, I don't like fish, but I like the metaphor of throwing a fishing net out. If I throw it out this far, I'm going to catch a certain percentage of the fish. If I throw it out further, I'm going to catch a bigger percentage of the fish. Does that just make sense? So here I'm only going to go 1 step out. If I went 2 steps out, I'd catch more of the data. That only makes sense. So how the shit do you do? Well, in the middle goes the mean. That makes sense because the mean is a measure of the middle. If I take 1 step down, where do I end up?
3.995.
Yeah. If I take 1 step up, 9.005. So did I catch the 2, the data point of 2? Nope. Let me bring up my list. Let me sort my list real quick. Make this a little easier. I did not catch a 2. What did I catch? I caught the 4s all the way up to what? All the way up to 9. So I caught how many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9. You definitely count repeats because that represents 2 different people, right? So I got 9 data points out of how many total? That's how you make a percentage, right? Part divided by whole. What is 9 divided by 12? 75%. Kicking the ass. Now sometimes it's possible for this to be 0%. Yeah? Let's see. Let's get a little more conceptual because you guys love it when I do that.
Question.
Yeah.
If theoretically your data point were exactly equal to the mean plus the standard deviation, would you include it or do you not include it?
Ooh, that's a good question. It depends on the kind. If you're dealing with continuous or discrete data. So in this case, it's discrete, and then it depends on what school you belong to. Statistics is the most interesting mathematics for a couple reasons. One, it's not all settled yet. It doesn't really affect us at this level too much until you start bringing in stuff like that. But there's big disagreements in some upper level statistics on how to interpret things and what methods to use. Students don't like to hear that too much, right? But oh well, this is the way it is. The other thing about statistics is it's the most honest math. Because we'll get an answer and then we'll say, nah, I'm about 90% sure on that answer. I mean, you can't ever get a perfect answer. Otherwise we'd all go play the lottery and win all the time. And everybody share the money. We all get like $2.50. $2. Oh, sorry. Are you guys kind of with me? So I love this about statistics. I actually love the fact that it's not settled. And it shouldn't be. Really, because it's the most directly real life math. And real life is messy, so of course the math is going to be messy. It's got to be. At this level, no. This level is pretty settled, right? But even that depends on who the hell you are. Normally, the reason I drew those parentheses is normally we don't include the endpoints. So to be honest, the more conventional way would be if the one was 4 exactly, you wouldn't include those. Maybe. So you have to truly be in there, not at the endpoints. But again, not everybody would agree with me. Let me see. So we're done with this. Good. What did I want to do? Yes. So here's something neat. Some more neat stuff about standard deviations. The reason I asked that last question. Let's see. Yeah, I'm going to do everything with you. Let me show you this. I love this example. Let's say this is ages of people in Florida. Like alternate universe Florida, right? I do lowercase Florida because I lived in Florida for a while and I'm allowed to put a lowercase up. If you've never lived in Florida, you don't understand. So where would the average age be? It looks about right there, right? That's the average age. If I go up and down one step, do you see how it's possible to not, if that's the step size, it's possible to not catch anything. So there's an old Russian dude, his name is Chebyshev. I always call him Chubby Dude, because I don't know if he was Chubby Dude. I've never seen a picture of this guy, but it just sort of sounds like what his name says. What he said was this. He said, for any, there's an N there, any collection of data within one standard deviation of the mean, there is at least 0% of the data. So that first statement is like, good job. What percentage? At least 0%. How long did that take you? But he gets a little more impressive on the second thing. You guys with me? And visually, you can see how that could happen. You have these really two disparate collections of data. It's possible to have nothing in the middle. Is this normally distributed? Shit, no. This is almost the opposite. Normal has everything in the middle, just about. This one has nothing in the middle, right? Second one, if I go out 2 steps, there will be at least 75%. Now that's really impressive. So what the shit? Look at visually, you can see. If I go out one more step, I'm going to catch some data, right? And what Shepherd said is it's going to be at least 75%. No matter what, if you just make up a list of data, this is always true. So the math behind this was impressive as shit. A little too much for us, but...
Should invent this man?
He came up with this theorem related to all data distributions. I like it. So he came up with this theorem. I like it. So this is called Chebyshev's theorem. Now watch this. Stay with me. This is ages of people in this alternate universe Florida, right? Can you imagine? He wants there to be, he says there's 3/4. What if I was, the alternate universe, one of the gods, and I said, I don't know how many gods you believe in. I don't care. And I said, okay, I want to escape this. Screw you, chubby dude. I'm going to make all these people older and all these people younger. I'm going to escape your step. If I do that, though, what happens to my standard deviation? It's bigger. So it still catches 75%. That's the fundamental idea behind why this thing makes sense. Why is it exactly 75%? Look up Chebyshev's theorem proof on the internet and try to get through it. But still, the idea makes sense. If I try to escape, I'm making my step size bigger. It's making it easier for me to catch you. It's like if you start running faster and that makes the cop run faster, then maybe. So if they really slow down, then they can both take a break. And then within 3, there's at least 89%. Is it 89, Jeff? No question. I think it's 89. Yes. Okay. It's like 88.8888. All right, so that's chubby dude. That's Chebyshev. What distribution does that work for? Any list of numbers you come up with, any will follow this rule. Period. Right? Okay. Maybe you guys are with me. Maybe. So is it okay that we got 75%? Does it follow the rule? Of course, because he just says at least 0. So it could be anywhere up to all of it. Right? Okay, now here's the more... this one I'm not as concerned with you remembering. You're all like, well, why did you tell? Shut up. I have to. It's ready for this. We have a very nicely behaved distribution, which is the normal distribution. It's got to look something like this. So that means that it's impossible to have 0 within one step, right? Automatically, you're not going to have 0s. No chance. And because of and if I make it skinnier, then the step just gets smaller. So the whole idea of what I talked about here is going to still apply. So this is really freaking cool. This is perfect. We round the numbers a bit, but still. So within one step, one standard deviation of the mean for normal distribution. By the way, this is called empirical rule. Within one step, there will be 68% of the data. There just will be. I think it's 68.26, but we just make it 68. Within one standard deviation of the mean, there was 68% of the data. Now here's how impressive this is. There's 2 more things here, but still. If I wanted to make... so what does that mean? Let's see. What does that mean then? Can somebody tell me then? All right, real quick, I want to make sure you guys understand this picture, if you can see it. If I go one step up and one step down, what are these numbers down here? They just represent the steps I'm taking, right? So the mean is 0 steps away from itself. If I take one step up, that's one step up. So these are actually z-scores underneath. So if there's 68% in here, that's what this thing says. If there is 68% in here, can anyone figure out how much is out there? How much is on that side? Careful, not 32. It's too much. Yeah, because there's 32% outside, 16% on that side because this is symmetric, right? So if I knew the average height of men and the standard deviation of men, I could design a door height so that 16% of men have to duck to get through it, right? If I knew the average hip width and the standard deviation of hip widths, I could design an airplane seat where 16% of the people won't quite fit in it comfortably. You guys with me? Of course, Americans, it's kind of expanding, so they had to make the seats a little bigger to get fewer complaints. So this is kind of like an analysis of how many complaints are we okay getting. You guys with me a little bit? Or like how wide you make your parking spots. There are some places where you're like, okay, what the shit? Sorry. So, just to finish this out, within 2 steps there is 95%, and within 3 steps, you've basically caught everything. There's 99.7%. So if you are more than 3 standard deviations in terms of height, you are freaking tall as hell. Right? I mean, you're going to get attention. People are going to walk out and look at you and go, well, dude, I don't see that all the time. Or if you are more than 3 steps down from the mean, you're going to get attention also. Right? Not because we're all rude, but because we don't see it all the time. If you saw Warwick Davis, you guys know Warwick Davis? Anybody? He was the main Ewok on, and he's in Willow. If you've never seen the movie Willow, shit. Right? But if you saw Warwick Davis, I don't know how tall he is, roughly there, you would do a double take, or you would notice, not because we're rude, but because that's unusual. And in fact, what we say is that anything more than 2 standard deviations away is what we consider officially right now to be unusual. It kind of jives with, so if this is the height, the average height of men, anybody out here or down there is going to be unusual. Not in a mean way, just not the usual thing I see. Right? What guys do we normally see? Guys in here. Out here is okay. Out here it's like, whoa, I don't see that very much. Okay, maybe. All right, this is all freaky, I know. Well. So the main thing, this is section 2.7, by the way. The main thing with 2.7 is that table we did to calculate standard deviation. Now, on top of that, they're going to ask you questions like figuring out the z-score, stuff like that. Or the one we did earlier, which was, what data point is 2 steps up from the mean? That kind of question is going to show up. What did I forget today? The first test is next Wednesday. So what I forgot to bring was the practice test. Shit. So I'm going to email that out. Somebody email me, remind me. I want to email that out. On Monday, I'm going to have the answer key for it. Everybody with me? So I'm sorry I forgot it. Just totally didn't even get in my brain. I've got it made. I just got to send it out to you guys. You can always stop by the office to get a copy. Yes?
What lessons did you go over?
Say again?
What lessons did you go over today?
2.7. 2.7 is a lot. Yeah.
Everything proved.
Yeah. So this first test is going to be chapter 1 and chapter 2. So you need to have all that homework done a week from today if you want it on time. Real quick, I don't know if I've said this yet. If you are not going to get every section done by the day of the test, you stop trying to get all the problems done. You start to do some out of every freaking section so you get practice. The most important thing with the homework is it's practice for the test. The second most important thing is getting it all done.
Stratify.
Beautiful. Stratify the shit out of that if you need to. Okay. All right. Did you make it? Yes.